Hello everyone. Today we're going to go through and see how many times our graphs might intersect. So what does that even mean? So let's take a look at what a graph might look like. We might have a quadratic and we might have a line, right? And we essentially in this unit want to find the point where these intersect, right? So let's make this a little bigger so we can maybe have a clearer idea, right? So maybe a parabola looks like this, and then we'll have a line that looks like this. Our end goal is to find, oh, right here, these graphs intercept. Where is this on our x value? Where is this on our y value? How in the world are we going to do that, right? First thing we need to do, before we even get into that, there's going to be a couple different answers, right? So if we have a line that looks like this, it's never ever going to intersect our graph, right? If that's a straight line and this is a parabola, they will never ever touch. Doesn't matter what your value, your x value is, they never cross, right? But if we move this graph a little bit, suddenly we're intersecting at 2 points, right? Or if we move it right here, we can see it's only intersecting at 1 point now, right? So we're going to have one of three answers: 1, 2, or 0 intersections. All right. So how are we going to solve this? Well, step 1, get the equations of both lines, right? So let's go maybe for the quadratic, y is equal to 2x minus 1 squared plus 1. Okay? And then for the line going through, maybe we can say y is equal to, let's say x plus 4. Right? So we have a stretched up graph that's 1 unit to the left, so somewhere like this. And then we also have a graph that intersects at plus 4 and just has slope regularly. Okay, so we're going to see, do these intersect or do they not? How are we going to do that? Simple. We just make these equal to each other. So let's start with 2 times x minus 1 squared plus 1, and we just make it equal to the other equation, because we want to know the point where these two are equal. Hope that makes logical sense. So a good way to do this is you're always going to want to expand this and get into standard form. So 2 times x minus 1 times x minus 1 plus 1 equals x plus 4. And let's FOIL this out. So x times x is x squared minus x plus 1, right? And we have all this multiplied by 2, and then we still have plus 1, and then still equal to x plus 4. And now let's FOIL out the 2, so 2x squared, this would reduce to negative 2x plus 1, and 2 times negative 2, negative 4x plus 2 equals x plus 4. Now let's move everything to one side and make one of the sides equal to 0. It would probably be easier to move the x plus 4 over. So we have 2x squared minus 4x. Let's bring the x over here over and make it negative x. Right? And then we have minus 4, and we still have the plus 2. And all we're left with on the right side is 0 now. So 2 minus 4, we're going to be left with negative 2. Minus 4x minus x, negative 5x. And then 2x squared remains unchanged, and it's equal to 0. So now this should be ringing some bells. Oh, we have an equation in standard form that equals to 0. Well, what do we always want to do when we see something like this? It's find the zeros. What I find the easiest way is, the most foolproof method is, you just go x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so this is the quadratic formula. We use it to fill out and find out where our zeros are. It'll tell us the x value, where these two coordinates align. Let's fill it out. So b value, negative 5. We're going to make it positive 5 because it has to be negative, right? And then b squared will have negative 5 squared minus 4 times 2, which is our a value, times c, which is negative 2, and divide the whole thing by 2 times 2. Alright, Inside the bracket, we're going to have 25 minus 4 times 2 is 16. 16 times 2 is 32. We have negative and negative, make it plus. Right, we have 5 over here, plus minus, and then on the bottom, 2 times 2 is 4. Now, 25 plus 32, what does that give us? Well, 27, 57. So we have root 57 plus 5 minus 5 plus or minus root 57 over 4. Okay, so at this point it's going to be helpful to get what root 57 is. I'm just going to do a quick Google search, root 57, and we'll call it 7.5 for the time being, just for simplicity's sake, but you would probably want to factor out the radicals if we're looking for a very precise answer. But for now, we have 5 plus 7.5 over 4, or 5 minus 7.5 over 4. And then this would be 12.5 over 4, or negative 2.5 over 4. And let's see what that is. 12.5 slash 4, we get 3.125. Let's just round it to 3. And then here we'll round again, and we'll just call it half, negative 1/2. So at roughly these 2 points, we would have an intersection, right? When x is equal to 3, we have an intersection, and when x is equal to negative 1 over 2, we have an intersection. Alright, so now to find the y value, so this means we have 2 intersections, right? And to find the y value, you can just plug this formula, or back into either of the formulas, because we know they're going to meet here. And in this case, it's going to be a little easier to do it for x plus 4, since it's a much simpler equation. But it'll give you the same result if you plug it into our quadratic as well, right? And to give you that exact, we rounded, so it might be slightly off in this case, but if you didn't round and you kept radicals, it would be straight on. But let's find our y value. So y is equal to x plus 4, x is 3, plus 4 equals 7. So our first coordinate where they're going to meet is 3 and 7. And then next we have y is equal to x, which is negative 1 over 2, plus 4. So you're going to be left with 3.5. So our next meet is going to be at x is negative half, and y is 3.5. And these are the 2 points where these 2 graphs will intersect. Alright? So, fun stuff, just make sure you equate them, and then once you equate them, move everything to one side. And once everything's on one side, use your quadratic formula to figure out where our zeros are. And that will tell you the 2 points where they meet. And once you get the point where our zeros are, fill it into your starting equation to get your y values. Okay? I hope that helped, and if you have any questions, just look in the description, you'll see how to reach out. Good luck!